Alright guys, you've made it to the last 2 weeks of class before finals. We're going to be continuing on with chapter 4 today, which we're still going to be working on solving quadratic equations. So far we've learned how to solve them by using graphing and using factoring. Today we're going to be solving quadratic equations using the quadratic formula. So when we're solving quadratic equations, graphing and factoring, like I said, are two ways that we can solve it. Factoring won't always be able to get you those factors, but using the quadratic formula is a way that you can always solve a quadratic formula. So in order to do this, what we're going to do is we're going to use this formula right here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Now remember, we're using the standard form of a quadratic formula where we have ax squared plus bx plus c equals 0. Remember, a couple keys here. A cannot equal 0 because then it wouldn't be a quadratic formula anymore. And everything has to be set equal to 0. So if there's anything on this side, we need to move it over into our quadratic formula. So for our a, b, and c in the quadratic formula, we're using our coefficients and the constant, the number that's by itself over there. Then a part of the quadratic formula, the discriminant, is the expression that is under the radical. It's the b squared minus 4ac part. Now, the last thing we're going to do in this lesson will have to do with that discriminant, but to start out with, we're going to be using this formula right here. This is one of those formulas that as you move on into higher levels of math, this is going to be an important formula for you to remember. So, let's do some examples here. Solve each equation, round to the nearest tenth if necessary. So as you guys are going through doing your assignment for this lesson, when it tells you to solve the equation, if you can solve it by factoring, I'm good if you go ahead and do it that way. Otherwise, you can use the quadratic formula. So this one, I'm going to go ahead and show both ways of solving it. I'm going to do factoring and the quadratic formula because, as you know, I like to show that we can get the same answers doing a problem multiple different ways. So if I want to factor this to start with, I'm going to start with my x, a times c in the top, which would be negative 24, b on the bottom, which would be negative 2. So I need two numbers that multiply to negative 24 and add to negative 2. It's going to be a positive and a negative. The negative number will be larger since they add to a negative. I'm going to use negative 6 and 4 here. So this will be x minus 6 times x plus 4. Set those both equal to 0, and I end up with x equals 6 and x equals negative 4. So that's solving by factoring. Now let's solve it using the quadratic formula. Again, quadratic formula, I have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So if I plug in my values now, negative b, you always want to keep that sign in front. So b is negative 2. Negative 2 would be positive 2. Plus or minus the square root of negative 2 squared minus 4 times a, which is 1, times c, which is negative 24, all over 2 times a, which again is 1. Now, if I go through and solve this now, I get 2 plus or minus the square root of 4 minus 4 times negative 24 gives me negative 96 all over 2. Now this will simplify to 2 plus or minus the square root of 4 minus negative 96. 4 plus 96 is 100 all over 2. So this will become 2 plus or minus 10 over 2. Now I've got a few different ways that I could go from here. I could split this into two equations. Since I have 2 plus 10 and 2 minus 10, I could say 2 plus 10 divided by 2, and I could say 2 minus 10 divided by 2. So 2 plus 10 would be 12 divided by 2 gives me 6. 2 minus 10, negative 8 divided by 2 gives me negative 4. Now there's even one other way. So again, I got 6 and negative 4. I could also take 2 plus or minus 10 over 2, and I can simplify this. 2 goes into each of these numbers, so that becomes 1, 1, and 5. So this then becomes 1 plus or minus 5. So then I would have 1 plus 5 equals 6, or 1 minus 5 equals negative 4. So even within this one method of solving, there's two different ways that we can get to those answers. Again, if you want to go ahead and factor if you can, I'm just fine with that. Otherwise, you can always plug it into the quadratic formula. Let's do another one here. 24x squared minus 14x equals 6. So this time, first thing I need to do is get everything set equal to 0. I need to subtract this 6 over. So 24x squared minus 14x minus 6 equals 0. Now, what I can do here is, just like I've said before, whenever you're solving these trinomials, you always want to see if there's something you can factor out first. So 24, 14, and 6, I can take a 2 out of each of those, which would leave me with 12x squared minus 7x minus 3. Now, let's see if I can factor this. I would have a times c, so negative 3 times 12 is negative 36. Then b in the bottom, negative 7. Now, two numbers that multiply to negative 36 and add to negative 7. We could do negative 9 and 4, but those add to negative 5. We could do negative 12 and 3, those add to negative 9. There are not going to be two numbers that we can get to factor here. So on this one, because we can't factor, we have to use the quadratic formula. So we're going to use this polynomial right here. You could use the original polynomial, but factoring out that 2 gives us smaller numbers to work with as we do our multiplication and everything throughout the quadratic formula. So again, negative b would be negative 7, so positive 7 plus or minus the square root of b squared, negative 7 squared, plus or minus, or sorry, this one is just minus 4 times a, which is 12, times c, which is negative 3, all over 2 times a, which again is 12. Now I just want to solve this. So 7 plus or minus the square root of 49 minus 4 times 12 is 48 times negative 3 gives me a negative 144 all over 24. So 7 plus or minus the square root. 49 minus negative 144 would be plus 144. So the square root of 193 all over 24. So now I'm going to take this and I'm going to make that 7 plus or minus. Here we actually, since they don't say to find the exact solution, they say solve round to the nearest tenth if necessary. That means even if it's not a perfect square, we still want to find the square root. So 193 says round to the nearest tenth, so that would round to 13.9. And then this is where I can finish it by setting it into two separate equations. So 7 plus 13.9 over 24, and 7 minus 13.9 over 24. So 7 plus 13.9 divided by 24. Again, rounded to the nearest tenth, that would give me 0.87, so 0.9. Then 7 minus 13.9 divided by 24 would give me negative 0.2875, so negative 0.30. And those would be my two solutions. So again, when we're solving these quadratic formulas or quadratic equations, again, like we learned in the last lesson, when we solve these, we're finding where this, if we were to graph this, where would it cross the x-axis? So this would cross the x-axis at 0.9 and negative 0.3. This would be one of those from that last lesson where if we graphed it, we would have said that it crosses between these integers. But now we're learning how to find the exact solution, not just saying which two numbers it would cross between. I'm going to go ahead and skip this one for now. This is another one that you could do factoring or quadratic formula. Let's go ahead. This is similar to that second one that we did. I'm going to go ahead, actually I'll walk through this one first. So 4x squared plus 2x minus 17. So if we look at this one, if we try and do it by factoring first, a times c would give us negative 68, b would be 2. Two numbers that multiply to negative 68 and add to 2. We could sit here and guess and check and see if we can figure it out, but I'm going to tell you right now, there are not two numbers that satisfy that. So we're going to go ahead and use quadratic formula. So again, negative b, negative 2, plus or minus the square root of 2 squared minus 4 times 4 times negative 17, all over 2 times 4. So this will give us negative 2 plus or minus the square root of 4 minus 4 times negative 17 gives me negative 272 all over 8, which this will now become the square root of 4 plus 272, so 276 all over 8. So now again, we want to take that square root, even if it's not a perfect square. If it's not, we're going to round it to the nearest tenth, which in this case would be 16.6. And then we're going to break it into our two equations from here. So negative 2 plus 16.6 over 8, and negative 2 minus 16.6 over 8, which would give us solutions of 1.8 and negative 2.3. Now I'm going to do one more here. Again, this is one where this doesn't start in standard form of a quadratic equation. So we have to go ahead and move things over to the left. But before I move them over, I need to distribute this negative. Having this negative outside the 7w plus 3 the sum of that quantity is just like having a negative 1 on the outside, which means I need to distribute that into my parentheses. So 2w squared equals negative 7w minus 3. Now I can go ahead and add both of those terms over to the left side, so that cancels. I now have 2w squared plus 7w plus 3 equals 0. So now I can go ahead and solve this. This one, I'm not going to start with trying to factor it. I'm just going to jump right into the quadratic formula. You don't always have to try and factor first. Even if it can be factored, you can still solve it using the quadratic formula. So negative 7 plus or minus 7 squared minus 4 times 2 times 3 all over 2 times 2. Now you notice that I'm not saying every letter and everything as we go through. You should be getting more comfortable with this, and you should be able to just pull those A, B, and C terms right out into your equation. So negative 7 plus or minus the square root of 49 minus 8 times 3, which is 24, all over 4. So negative 7 plus or minus the square root of 25 over 4 would be negative 7 plus or minus 5 over 4. So negative 7 plus 5 over 4 and negative 7 minus 5 over 4. So negative 7 plus 5 would be negative 2 over 4 would be negative 1/2. Negative 7 minus 5 would be negative 12 over 4, which would be negative 3. So again, those are just some examples of solving these equations using the quadratic formula. Let's do a story problem now using this. The height h of an object t seconds after it is propelled upward with an initial velocity of v is represented by h equals negative 1/2 g times t squared plus v times t plus h. So we know that v is the initial velocity. We know that g is the gravitational pull, and we know that h is the initial height. Suppose an astronaut on the moon throws a baseball upward with an initial velocity of 10 meters per second, letting go of the ball 2 meters above the ground. How much longer will the ball stay in the air on the moon than a similarly thrown baseball on Earth? So, we have that, let's see, initial velocity, we used red, so it has an initial velocity of 10 meters per second, and then that 2 is the initial height. Let's see, letting go of the ball 2 meters above the ground. So using our color coding here, that 2 meters is going to be going in for the initial height of the ball. So then we need to know the gravitational pull in order to solve this. So let's go ahead and solve on the moon first. So on the moon, that gravitational pull is going to be 1.6 meters per second squared. So using our color coding here, let's plug in the values needed. So our original equation, we would have negative 1/2 times g, the gravitational pull, which is 1.6 times t squared, plus the initial velocity, which we knew was 10 times t, plus the initial height, which we know is 2. So now if I multiply this 1.6 by negative 1/2, I'm going to get negative 0.8 t squared plus 10t plus 2. So this is one of those problems where we look at it and we think, man, that's a lot of words. This stresses me out. I don't even want to think about this. But if you really think about it and pull out that necessary information, all we're doing is plugging numbers into our equation that we're given. We end up with this polynomial right here, and now we just need to solve it. And we can do that by using the quadratic formula. So I would go with negative 10 plus or minus the square root of 10 squared minus 4 times negative 0.8 times 2. So this will give me negative 10 plus or minus, if I do 10 squared, I get 100, minus 4 times negative 0.8 times 2. If I do all of that, that's going to give me the square root of 106.4. Oh, I forgot my 2a. Over 2 times negative 0.8, so over negative 1.6. So now negative 10 plus the square root of 106.4 rounded to the nearest tenth is going to give me 10.3 over negative 1.6, and then I'll have negative 10 minus 10.3 over negative 1.6. And I'm going to come up with two answers here. One is going to be negative 0.2, and the other one will be 12.7. Now in this case, when we solved it before, when they just told us to solve the quadratic equation, we said that both of these were solutions. But on this one, if we think about it, we're trying to figure out how long will the ball be in the air. A ball can't be in the air for negative 0.2 seconds. So in this case, our solution would be 12.7. Now we need to go ahead and solve for the Earth. Now in this one, we're going to use all of the same information. The only difference is that we have a stronger gravitational pull on Earth. So instead of 1.6 for the gravitational pull, we're going to use 9.8. So negative 1/2 times 9.8 t squared plus 10t plus 2. We still have the same initial velocity, the same initial height. So this will give us negative 4.9 t squared plus 10t plus 2. And now I'm going to go ahead and solve this again using the quadratic formula. So negative 10 plus or minus the square root of 10 squared minus 4 times negative 4.9 times 2, all over 2 times negative 4.9. So that's going to give me negative 10 plus or minus the square root. If I do everything under my radical there, which again is called my discriminant, that is going to give me, let's see, negative 4 times negative 4.9 times 2. I'm going to have 10 squared, so 100 plus 39.2, so 139.2 all over negative 9.8. So negative 10 plus the square root of 139.2 would be 11.8. Whoops, not over 2. Over negative 9.8. And then negative 10 minus 11.8 over negative 9.8 would be, let's see, negative 10 plus 11.8. That would give me negative 0.2, which again we know cannot be the solution. Negative 10 minus 11.8 divided by negative 9.8 would give me 2.2. So we know that the ball will stay in the air for 12.7 seconds on the moon and for 2.2 seconds on Earth. They ask us, how much longer will the ball stay in the air on the moon than on Earth? So to get our final solution, we want to take the length on the moon, subtract the length on Earth, and our answer would be 10.5 seconds. So the ball would stay in the air for 10.5 seconds longer on the moon than on Earth. All right, last thing, like I said, is getting into those discriminants and how to use the discriminant. So again, when we have our quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, the discriminant is the part that is under the square root symbol. It doesn't include the square root or the radical. It's just that b squared minus 4ac. So, using that discriminant, the value of the discriminant can be used to determine the number of real roots for a quadratic equation. So real roots, again, is how many times does it cross the x-axis. So, when you find the discriminant, if it's negative, the equation will have no real roots, since no real number can be the square root of a negative number. So no real roots means that it will never cross the x-axis. Like we talked about last time, that's one that will look like this, where we said no real solution. Next, if your discriminant is 0, the equation will have a double root, which again means that there is one real root. So a double root was where our parabola touched but didn't cross the x-axis. So we just have that one root where it touches. Then if it's a positive discriminant, the equation will cross the x-axis twice, meaning that it has two real roots. So that could look something like that. Again, it could be opening up or down. So let's quickly walk through some examples of how to use our discriminants here. So first, we want to state the value of the discriminant for each equation. Then we want to use the value of the discriminant to determine the number of real roots of the equation. So for this first one, again, discriminant is b squared minus 4 times a times c. So in this case, 10 squared minus 4 times 2 times 11 would give us 100 minus 8 times 11, which is 88, would give us 12. We have a positive discriminant of 12. Since it's positive, that means that there will be two real roots. And again, they wanted the value of the discriminant and how many roots you would have based on that value. Now this one, 3m squared plus 4m equals negative 2. Again, you always want to have it set equal to 0. So 3m squared plus 4m plus 2 equals 0. So our discriminant would be 4 squared minus 4 times 3 times 2, which would be 16 minus 12 times 2 is 24. So our discriminant would be negative 8. Since we have a negative discriminant, that means that there will be 0 real roots. And let's do one more here. Discriminant would be negative 20 squared minus 4 times 4 times 25. So negative 20 squared would give us let's see, not negative. It would be positive since it's a negative times a negative. 400 minus, let's see, 4 times 4 is 16 times 25 is 400. Gives us a discriminant of 0, which if you remember from that last slide, a discriminant of 0 means that there is one real root. So that would be a double root. It would touch our x-axis. So that's what you guys will be doing today using the quadratic equation, or quadratic formula. There's your homework. 497, you're doing 10 through 36 even, and 45 to 46. Again, like I said, we're in our last 2 weeks before finals, so make sure that you guys are keeping up on this homework, getting anything turned in that you're missing, so that you can be going into that final with as strong of a grade as possible.